A man who can row a boat at 3 meters per second in still water wants to cross the river from A to B as shown in the diagram. AB is perpendicular to both banks of the river. The river is 50 meters wide, as we can see, and it's flowing at 1 meter per second in this direction. So he points his boat at this angle alpha. Now, if we just complete this triangle by putting the 1 meter per second this way, this is the resultant, that he goes straight across. So we can easily find this angle, which I'll just call beta. So this is the opposite, this is the hypotenuse, so we'll use the sine. So sine beta is going to be 1/3. And so we can find beta. Now my calculator from the last question is in radian mode, so I need to pop it back into degree mode. And I'm going to do the inverse sine of 1/3. And that's 19.47 degrees. And that means that alpha, since we know that's a right angle, is just 90. Take away my last answer, and that's 70.53 degrees. Correct 2dp. Okay, the resultant speed of the boat. So that's just this third side of the triangle. So we can do that just using Pythagoras. So that's going to be the square root of 3 squared take away 1 squared, which is the square root of 8, or 2 root 2 meters per second. I don't think I need a calculator answer. If I can give an exact like that, that's fine. And then we want the time taken for the boat to travel from A to B. Well, that's just going to be the distance, which I believe was 50 meters. Let's just go back and check. Yep, that's 50. Divided by the speed, which is 2 root 2. So we've got 50 divided by 2 times root 2. Oh, I need to be careful there. Remember my BIMDAS. Let's just bung a bracket around the 2 root 2 to make sure it's on the bottom. I probably should have used a fraction template and done it like this. But so that's going to be 17.7 seconds to 1 decimal place. On another occasion, the man points the boat in the same direction, but the river speed has increased to 1.8 meters per second, and as a result he lands at the point C. State the time taken for the boat to travel from A to C, and hence find the distance BC. This is only 2 marks. At first glance, it looks to me like we might be needing, so he's pointing this way, and we know that this angle was 70.53. And then the order is now going at 1.8. And it looks like we might need to use the cosine rule. It's only 2 marks, so I'm thinking there must be something easier. So what I'm going to try is the fact that we know that when the water speed was just 1, that he was heading across here. The resultant of this and 1 was that this was actually the square root of 8 going across there. And then we'll put 0.8 here for the extra speed that we now have. And I think that this has got a chance of working. So if this is the case, then the time is going to be the same, because he still has to span 50 meters across, and he's still got the same component in this direction. So we can say that t is equal to 17.7. So that's all good. And then I think we can use a similar triangles thing. That's root 8 and that's 0.8, but we know that this is 50 and that's x if we look at the distance across the river. This is BC. So x over 50 must be the same as 0.8 over root 8. So x is going to be 50 times 0.8 divided by root 8. So 50 multiplied by 0.8, and divide that result by the square root of 8. And that's 10 root 2. I might just give that as an exact answer. If we did give it as a calculator answer, it would be 14.14, say, 14.1.